All right, hello, gang. So what we are working on now is activity 322 for digital electronics, the PLD mode here. Okay, this is this one here is going to be a 3-bit mod 6 up counter. So it's going to count from 0 to 5 because that's 6 different mods: 1, 0, 1, 2, 3, 4, 5. And that's what we're doing here. So if you look here, the way they've got this set up, that's what they've got from 0. So if you look here, this is a NAND gate here. So the NAND gate, remember, sends out a 0, 1 when we don't have 3 1s here. It's the opposite of an AND gate. But when there are 3 1s here, it will send out a 0. And since these are um, they reset at low and they just run normal at high. This is a 1, it's running normal, but then when these 3 are 1s, it sends 1s here. So if you look at this here, you've got, let's go, now I'm going to go to and also a couple other things is the 74LS34, they don't have that in digital, in the design mode. They have it in design mode, but not in the PLD mode. So you have to use this DECB CD-7 for the decimal binary coded. Also, something else to understand is that thing is a common anode digitizer there. So we've got it sends the numbers to the 7-second display, but a common anode. And on our boards, they're common cathodes. So we just have to switch it around, and I'll show you that in a second. So here's the circuit right here. Okay, here's the 3 bits. This is just right now. This is just counting from 0 to 7. So if I hit play here, you'll see 2, 3, 4, 5, 6, and then 7, and resets to 0. Okay, that's what's going on right now. But if I want to make it a 0 to, well, I'm gonna make mine a 2 to 5 counter. Okay, that's what I want to do, is make it a 2 to 5 counter. So what I'm gonna do is I'm gonna come in here, I'm gonna grab my NAND 3-input NAND gate. Hit OK, click here, hit cancel, close here. Then I'm gonna flip this, right mouse click, go to flip horizontally. And now what I've got to do is I've got to think through this. How do I want this to work? So I take out my notes here. I've counted from 0 to 7 in binary. I know I want to go from 2, which is 0, 1, 0, to 5, which is 1, 0, 1. But remember, with an asynchronous counter, we have to go to 6 to reset at 5. So I want to reset when it's 1, 1, 0. So to do that, I've got my gate here, right? And I'm going to go 1. So if you look up here, I've got this one's connected to this one here. This is my most significant bit. This is my least significant bit. So this least significant bit here goes to this first flip-flop. This one goes to the second flip-flop. And this most significant bit one right here goes to my third flip-flop. So I've got this is my least significant bit. And this bottom one here is my most significant bit right there. Or that's my least significant bit right there, right? My most significant bit is here. So I want 1 there, I want 1 there. So my first one's going to be a 1, which goes up to here. My second one is also a 1, so I'm going to go to here. Since this only goes on when it's high, right? So and then this one here, the third one though, I've got to go to my least significant bit. Since I want a 0 here, but I want this to be a 1, I've got to go to my Q bar. So when this is at 0, Q's at 0, or this one's at 0 here, Q bar will be at high. So now I'll have a high here, a high here, and a high here. And that will give me my 0 coming out. So now what I want to do is I want to come through here and get rid of all of the connections here and go, okay, so I want this is already reset, but I want it to reset and go back to 2, which is 0, 1, 0. So I want this one to be cleared out here to 0. I want this one to be cleared out to 0. This one's just going to go to high because it's just running normal. And then I'm going to have this preset go to 1. So when this goes on, I want this one to be high, these two to be low. So I'm going to come over here and set that up like that, and then hit play here, and then just go through it. See, now 5, now it goes back to 2, 3, 4, 5, 2, and so forth. Okay, so let me stop this here. I'm going to make this bigger here so you can see it better. Then I'll come off of it here. So now you can see this. I'm going to move this over to my PLD running right now with it. So I'll set this up for you to see it here. Hopefully you can see that well enough. Let me try and see. Actually, I'll bring it down here. I don't know if you can see it real well there. Maybe that's better there. think you can see it there. So it's going 3, 4, and then it goes to 5, and then it resets at 2. Hopefully you can see that there. Yeah, you can see it. Okay, good. So you can see how that's, so basically what we've got here is you can see the bits going up there and the numbers are going here. The way this dig 1 and dig 0, they're up here. If you look up here, you'll see next to the power to the left, it says display. In that area there, there's display A, B, C, D, E, F, G, and then it says dig 1, dig 0. Now remember how we had put inverters on, and I'll talk about that in a second. Since this is a common cathode, 7-segment display, we have to put inverters going out of that display on the PLD on multi-sim, going out to make it, and I'll talk about that in a second, show you that more. But so what I do is I have to go from ground to dig 1 there, and that's this one right here. If I go to dig 0, it goes to this one here. So there's 2 7-segment displays, okay? If I put a wire in there to run both of them, it will be, the same numbers will be coming up here. This is what's going on here. We're counting up to there, okay? Okay, that time I paused it while I was moving the tripod to show it. So hopefully that you saw that. Now what I want to show you is up here. Here's that digitizer we were talking about that takes our different bits in there and converts it into the A, B, C, D, F, G for our 7-segment display. Here's my pin outs. These are all outputs going to the board. They're all P42, 43, 45. All of them go into those little A, B, C, D, F, G related to these, okay? Now here's where I'm talking about the inverters. We had to put inverters here because, again, this is a common cathode or a common anode, so it would be positive over here since the common part would be the positive part. But now because this is our board is a common cathode display, we just had to put inverters here to switch it from coming out here. Instead of coming out here at 0, it's coming 0 here, then go to 1, and then it goes out to the ground, which allows it to run, okay? Now, if I wanted to go ahead and all I have to do to go from a 0, like you have to do for the assignment, from a 0, reset it at 5 and go from 0 to 5, I just have to take this one out, put this one up to my high, and then this one is going to go from high to my reset AND gate right there. So now I'll have to play. You'll see it work here. 2, 3, 4, 5, and then reset to 0. And that's all that's to it. Okay? Let me know if you have any questions.